Heya, and welcome to the video. My name's Lockie, I'm a Microsoft technical trainer. It's good to have you with us. In this video series, we are going to be looking at load balancing options in Azure, specifically focused on non-HTTPS based traffic, the sorts of things that you would pass between normal servers. Now, there are a number of load balancing options in Azure, so we're going to go through them one by one. But before we get to that, I want to make sure you've got a good overview of what is available and how you pick the right one. So we will explore the options that are on hand, and then we'll look at them individually. First, Azure Load Balancer, great for regional-based workloads, and Azure Traffic Manager second, which is perfect for any sort of multi-regional based deployment. We are going to look at the options that are available to you for load balancing in Azure. But we're specifically just looking at the stuff that is non-HTTPS, and I want to give you a bit of a pathway to pick the right one. In Azure, there's four main options for load balancing, no matter the type of workload you're going. And we are looking at the ones on the right-hand side of the screen here. We have Azure Load Balancer, useful for some regional workloads and things where we need to direct one input to multiple outputs. We also have Traffic Manager, a great multi-regional option where you need to balance things between different endpoints in different locations. Between the two of them, you're going to find the thing you're looking for any sort of non-web-based workload. When I say web, I mean HTTPS style traffic. Just gets tiring saying that all the time. So, if these are the options that are present for us, how do we pick the right one? Well, there's a couple of different ways to go about it, but my personal preference, and the thing that I always did with my customers out in the field, was to go to the load balancing decision tree. There's an interactive version of it available in the Azure portal, or the one that I'm going to show you is available in the Azure Architecture Center. The first woe-no-go position is your application a web-based one, HTTP or HTTPS? Because the answer is, if it's not, there's two main options for you and some really quick decisions that'll tell you which one or the other or combination of the two is going to be right. Ultimately, following this tree leads you pretty quickly into either a load balancer on its own or Traffic Manager with some combination of load balancer in the back end. Now, there are many other architectural solutions that involve these two in combination with other services as well. And I recommend checking out the example architectures available in learn.microsoft.com. When you try and make the decision for this one, think about the application, how it's going to be hosted, what the availability requirements are, as well as where it's actually going to be scoped. If it's only running in a single region, you may only need that load balancer alone. We make decisions like this ourselves. We use these services extensively in the Azure ecosystem. So, know with confidence that this will do the job nicely for you if you need it. Up ahead, we're going to be looking at Azure Load Balancer. And I want to look at how you design for it. Knowing where it fits, where you kind of use it, some of the limitations and some of the structures around it are really important to know you're making the right call. So we're going to be looking at not only the load balancer itself, I want to show you the basics of it, but also a few different options that are available. Things like the Gateway Load Balancer, which have a really specific purpose to do with network virtual appliances. So let's dive into it. So in front of us, we have a pretty standard two-tier web application. At the front, we have a web tier, and the back we have a business tier. And the load balancer is facilitating the ability for this to work. At the front, we have a public IP. This is a public load balancer. And the public load balancer is going to receive requests from users, and it's going to redirect from that one input to multiple outputs in the back. Now in the back there, those are going to be virtual machines, either statically created into that backend pool, which is what we call where those servers live, or you're going to use virtual machine scale sets to be able to dynamically scale up and down based on request load. Load balancers also work between different tiers of an application though. We can easily use a private IP as the front end instead, and look to the bottom half here, where we are directing traffic between the front end and the back end together. This means that Each tier of the application can scale independently of one another, and we can use different rule sets to redefine what port something comes in on, and if we need to translate that to another port, that's a very easy thing to do. So the load balancer is about taking in traffic, distributing it amongst the different backend servers that are there, and then ensuring that everything stays scalable and functional at all times. I mentioned that gateway load balancer in the intro to this, and it is a bit of an unusual one. It's designed for one particular purpose. I am someone who is running third-party network virtual appliances. Could be a firewall, could be a security device. There's a whole range of different reasons why we look to these third-party appliances to extend the capabilities of our network infrastructure. But what the gateway load balancer allows us to do is take that input traffic that a user has, that unfiltered traffic, pass it through to the network virtual appliances in the backend, which could be in a VM scale set or individually deployed. Then we can easily ensure that any traffic that is going to hit our application in the backend has been through our security systems, has been analyzed by firewalls. This is something we really only need for those third-party appliances. First-party firewalls like Azure Firewall are not something that we need to roll a gateway load balancer for. But if you are looking to integrate with any other system like this, it's extremely useful to have this on hand and be able to redirect that traffic through and ensure that it is having the full packet analysis applied to it or is being run through that intrusion detection system that you are using. All right, enough about the gateway load balancer. Let's roll back to just the normal Azure load balancer, what I covered in the whiteboard there. Depending on where you deploy your load balancer, some regions support availability zones, and so does Azure Load Balancer. You can either deploy them in a single zone at a time, like we're seeing on the right-hand side. I've known a few customers to actually do this, where they effectively provision each zone like it's a totally separate region. Zone 1, Zone 2, Zone 3, and then we balance across the three. Or, and this is the preference that I tend to go with, we can have a zone redundant load balancer. One input spread across multiple different zones, redundant, safe, and we can distribute traffic amongst each zones freely. Now, if you enter a region that does not support availability zones, don't fret. All you need to do is deploy a load balancer and you're already going to be getting effectively that single zone structure there. One load balancer in, multiple outputs on the back end. The last kind of important thing to talk about with load balancers is the SKUs. SKUs, or t-shirt sizing if you like, tells us the different options that are available for something, maybe different pricing models or different sizes. With the two that are available for load balancers, I can tell you with certainty, near 100% of the time, you will be picking the standard SKU. This is the one that supports security by default. It has an SLA associated with it, and it also allows for inbound and outbound flows. So we can control traffic on the way in, and we can also control traffic on the way out and ensure that everything's using just that one ingress-egress point to talk to the broader world. Basic load balancers in the basic SKU are much simpler. They don't support secure by default, they don't support a lot of security things, and they don't even come with an SLA. So we really only use them for sandpit style testing. Additionally, they are on the process of being phased out and retired. So I will always recommend that standard SKU above all else. There are going to be a few other options in terms of a global load balancer as well. This is one that's used for some very particular scenarios, and I'd recommend heading to the Microsoft Learn documentation pages over at learn.microsoft.com to find out more about if a global load balancer will fit your particular scenario. We're going to be looking at Azure Load Balancer configuration. After you decide that it's the right choice for you, there's still more steps to go. We need to make sure that it's created in the right way, it's got all the right configuration, and that it's going to load balance the traffic that you want to the place that you need it to go. Additionally to that, there are a few really important pieces of configuration around health probing and persistence that we need to consider that are all going to be based on your individual application, the thing that you're actually going to have the load balancer front. We'll go through all the various options, take a look at what's available, and I'll make sure that you've got the lingo to understand what all these various bits and pieces mean. Let's dive in. So here we are. This is the process for creating a load balancer in the portal. Don't stress about this right now. I'm going to show this to you later. But there's a couple of things that I want you to focus on as part of it. The first is public. Choosing a public or internal load balancer is something you do on creation. So you need to have decided already, architecturally, is this something that people are going to come in from the broader internet via a public IP, or is this a load balancer for an application that is running internal to my systems? Doesn't matter which one it is, just pick the right one. Now the second thing is the SKU. There are two SKUs currently available for load balancers, standard and basic. I will recommend 100% of the time to pick the standard SKU unless you are in a sandpit environment and testing things out. The basic is limited in a number of ways, one of which is that it does not have an SLA attached to it. So if something goes wrong, it's kind of no real help for you there. The standard load balancer does have that SLA there. Additionally, it's got lots of extra security configurations by default. So always the right choice. Beyond this, it's really just about picking all the various pieces that surround the load balancer itself. Of course, it's going to need a name, it's going to need a region, but the rest of it's about attaching things to it. So we have our load balancer at the top. What's the next thing we need? We need somewhere to send the traffic. So the thing you will be creating is a backend pool. Backend pools contain all of the virtual machines or endpoints that we're looking to reach out to. And Azure Load Balancer supports three different things. Unassociated, i.e. there's nothing in here. This is just a place for us to send traffic. Individual virtual machines, created and added one at a time to add into the pool. If you're running an application that you've migrated from on-premises and it is not dynamically scaling, you can still use a load balancer with 2 or 3 virtual machines to ensure the application runs smoothly. And the last of all is that virtual machine scale set. You can configure it with the scale set here to give you that flexibility and scale over time. A standard SKU is able to support up to 1,000 simultaneous instances in the backend pool, so it's extremely flexible if that's what you're looking for. Note that we also do support availability sets and other types of high availability scenarios with virtual machines as part of your backend pool here. So configure it however you need. All right, next step. Load balancer at the top, a pool in the backend. These two things still don't have a way to send stuff between one another. For that, we need to create some rules. The things that are going to mash and match from traffic that comes in through the front and then pass it along to the back. Your load balancer rule sets begin with a simple name, just something to call it so you remember what it is. And then it's all just about mixing and matching the pieces. What front end are things coming through? What port and IP combination do you need to actually get the traffic where it needs to go? You will also want to configure a couple of things around session persistence and health probes. They're the last two sets down here. We're going to talk about those individually, and session persistence is the first thing that I want to focus on. This is incredibly dependent on your application, but know that there is 3 different options available for session persistence. This is the idea that if a user comes in, we've got connection 1 at the top here, we always want them to go to virtual machine 1. Think about this maybe like you've got a shopping cart on that VM. Something that is stored that is unique to that user that we need them to keep going back to over and over again. Session persistence is incredibly useful if your application needs it and your application supports it. We've got 2 different methods of checking that someone is the same every time, either by using their client IP or a combination of IP and protocol together. We're actually doing a 5-tuple hash check, which is the 5 things that you see listed down here to check that a user is who they say they are, but we configure this session persistence to make sure that it's the right people. Now, the other thing that you do need to consider is that there isn't any graceful draining of customers if one of these VMs goes down. So you need to ensure that your application is going to handle a cutover from one VM to another in a meaningful, graceful way where the user's not going to be impacted. Again, these are all considerations as part of your architecture and things you just need to be thinking about. All right, last and most important, how do you know that one of these virtual machines is ready? It's up and running, that someone can actually get on there. It's a health probe. Nice and simple. Send a little request to the machine. Hey, are you alive? And it replies back, yeah, I'm alive, ready to go. That's it. That's all we need to know. We typically recommend a HTTP request, so like a little web server that you can run. This means that you can check to see the backend DBs up and running and everything's connected properly. But if this isn't possible for your application, don't stress it. We can also do custom TCP probes. They're just a little bit less accurate, I would say. TCP probes tell us that the server is alive, but it doesn't really tell us anything more than that. A custom probe with HTTP means you can return error codes, so you can say exactly whether this is running or not. Of course, pathing, interval, make sure that you're setting these correctly. Is every 5 seconds quick enough? Is it too quick for your application? This is all things you'll just need to consider as part of your design. Now, there is one little thing that I have on my list at the beginning that I haven't talked about yet. It's outbound traffic. Most of the time when we're dealing with load balancers, we only ever really think about traffic coming into our environment. I am a user wishing to access an application. I want to make sure that my virtual machine that I am accessing is up, but I don't care which VM I'm getting to. As long as I get to the right one every time, I'm set. Now, everything I've talked about so far has been inbound. Traffic coming in and getting to the right virtual machine. We've got health probes to check that everything's up and running, all of that. What I want to focus on now is the other direction. Standard load balancers support both inbound and outbound rules, which means we're able to perform network address translation, both for destination NATing. I want to come in and access a specific virtual machine, set up a rule accordingly. Set one port to go to one VM in the pool. Not a problem. But we can also do it on the way out. This means that virtual machines in the backend pool don't necessarily need their own public IP to be able to talk out to the web. We can actually control it, and so everything in that back end communicates through one or more IPs that front your load balancer there. This is extremely good if you want to ensure that, well, maybe an application knows that this IP, whether it's coming in or out, represents that whole load balancer pool as a whole. Maybe you want to just obfuscate which virtual machine's actually talking out to the internet. There's many good reasons that you would want to do this, but having an easy SNAT and DNAT option available directly in the load balancer like this, it can solve so many small problems along the way. It's the band-aid of the network world, and we want to make sure that it's simple for you to be able to put in place. Whether it be for just reducing the number of public IPs you have in an environment, always a good option for your security perspective, or if it's about just making sure that everything's nice and neat from an administrative point of view for your firewalling team, this is here to help you. Make sure you use it when you need it. All right, let's jump into the portal. I promised I'd go across there and show you a few things, so let's go and create a load balancer. I want to show you how it's all done. All right, we're in the portal now. Let's create a load balancer, and I want to focus on the public load balancer, something coming in from the internet. We're able to route to a pool of virtual machines in the backend. We're going to hit create here, and this is going to open up a dialog that allows us to just go step by step and see that there is quite a few things up the top here. We've got the basics that we need to configure, name, region, that sort of stuff, as well as front end, back end, and inbound and outbound rules. The great thing about a load balancer is you don't have to configure all of this right at the beginning. We can create a load balancer and change and add configuration over time as our environment becomes more complex or as the architecture grows. So start with the basics, work from there. Let's head on down to my resource group. I'm going to put this in my core networking group, and we're going to just make a quick load balancer 001, nice and simple. Here are the 3 different options for SKU, and do note that that basic is in the retiring soon section, and standard is our recommended one. So pick that unless you've got another reason. We'll pick our public load balancer here, and we will pick a regional. Global load balancing is a very specific option, and if you'd like to know more details about how that functions, head on over to the Microsoft docs at learn.microsoft.com. There's a huge amount of details about where that can be useful for you when you need to split a load balancer across multiple regions. All right, front-end IPs next. How are we getting into the environment? Well, it's a public IP, so we need to add one. You can either add an existing one, just pick one from the region that you've already got, or you can create a fresh one. Simply pick either a single IP address or a prefix, and you can always go through and pick multiple public IPs at a single time. When you hit add, this will add this in to the front-end IP and notes that I haven't yet created it, so something we need to make fresh. The next thing is backend pools. Where are we sending the traffic to? Well, again, add a backend pool, create a name, and tell us where we're going to land it. Note that even though this is a public load balancer, we still need to target a virtual network, because the idea here is that we are coming in from the internet and reaching a private set of servers. None of those servers will require a public IP, so this is going to be our ingress point. We'll pick one of our spokes here, and then we can easily go through and target individual NICs, or you can just target a whole bunch of different IP addresses. What is great is that I don't actually have to add anything here right now. I can just hit save, and I can choose to add things to my backend pool later. So we can go through and create that. Oh, of course I'll need that there. Additionally, once we've got our load balancing backend rules, we can create our inbound and outbound rules. These are just configured on the fly based on what's required for your application. We need to set what front-end IP we're using, what backend pool we're targeting, all of the bits and pieces like that. All right, I've run you through this. I'm going to show you a provisioned load balancer so we can look at a few things around health probing and different backend pool configurations. See you back here in a tick. All right, welcome back. So here is our complete load balancer that I've already pre-provisioned. Baked the cake earlier. Let's go take a look at a couple of pieces about it around how I've configured this out. I want to look at the backend pool and also the health probe. So top left-hand corner, I'll open up my side menu. I just want to scroll on down to the backend pools first. Here we have a backend pool, which I've actually configured 3 separate virtual machines in. These ones are part of a VM scale set. We can see their individual private IPs, and we can also see exactly what availability zone I've deployed them in. This means I've deployed my load balancer in an availability zone configuration, working across all 3. We can also see a few things around resource sharing and exactly the number of rules that apply to this pool. Little pieces that are extremely useful for you to be able to just get a quick pulse check of how your environment is running. Now, in terms of the health probes, we actually configure those separately and you apply them on a rule basis. So if we check our health probes here, I have a simple TCP port 80 request that I put through. I've actually gone for something a little bit simpler than the HTTP style request. This is your call on how you want to set this up, but putting in your thresholds like this can really help define how your application needs to run. Set the interval in a time frame that makes sense for you, makes sense for your application, and checks the right thing. Once you've got all of that in place, you're set, you're ready to go, and you're good to start configuring those rules. We're going to be looking at some design principles for Azure Traffic Manager. Now, when we look through Traffic Manager, there is some things that we need to know in terms of terminology, as it is a little bit unusual compared to other things within the networking ecosystem. We're going to be looking at how it routes within networks, how you can route to different endpoints, and what the profiles are within a traffic manager, as this is a global service. It's not tied to a single region. All right, let's begin with some use cases, because that is the easiest way to get things up and running. What you're seeing here is the simplest architectural design that I have for Traffic Manager. We have a primary and a failover endpoint. Two different copies of a web server that are sitting there, just firing away. And if anything ever goes wrong with our primary, we want to make sure that we can easily fail across to our secondary. Traffic Manager is designed for this scenario. Now, it can do many other things beyond that, but this is its core tenet principle. The ability to direct a user from one endpoint to another based on health. Now, how we decide which endpoint to go to, that is dependent on your configuration, because there is a lot of different configuration things that you can do in place. If you want to use this primarily for availability, absolutely. Primary secondary failovers is simple. But we can also use this for multi-site application performance optimization, running a few copies of an application and directing traffic accordingly between the different sites. This is your call on how you want to use it. It is versatile and straightforward to use. So let's dive a little bit deeper. If we take this at the higher level architecture, let's look down in the depths of how this actually works. Azure Traffic Manager leverages how DNS queries function. So what happens is that a user will request a site in this particular case, and they will be redirected across to the recursive DNS service in Azure. In this particular case, someone is requesting contoso.com, and we have done a CNAME redirection across to Traffic Manager. What happens next is Traffic Manager analyzes the request that the user has put forward, and then it returns the best endpoint to them. Best, that's something we're going to define in a moment. But regardless, once it has come back with what that best looks like, it passes back to the user the direct endpoint. Straight to the site, straight to the URL, straight to the IP, whatever it is. This is a really sneaky way for us to drastically optimize how a user gets to the right location. There's no redirecting through multiple regions. This is happening all at the Microsoft Edge locations, the first moment that a user enters our network environment. So, what is best? It's a good question. What does best look like for your application? If you're running 2, 3, 5, 10 different endpoints all around the world, how do we decide where a user gets redirected to? This is done by selecting the traffic routing method. Different methods lead to different outcomes. Now, priority is by far the simplest option. You have a list of endpoints, you have a primary, a secondary, a tertiary, and you just work your way down the list. If the health check returns that the primary is down, send the user straight to the secondary. Nice and easy. But what if you're looking instead of availability to try and leverage some optimization? Well, weighted might be a better option for you. When you choose a weighted method of redirection, we will direct users to any and all healthy endpoints in the list based on the weighting you put in place. We have three numbers here, 50, 5, and 50. So, for every 105 users that come through, 50 get sent to region A, 50 get sent to region B, and 5 users will get sent to a test site. Now, this is extremely useful if the thing you are trying to do is optimize and increase the performance of your site. If your developers want to live test a small portion of traffic to just see if their improvements are actually making positive change, you can do this entirely using Traffic Manager. If at any point an endpoint goes down, not a stress. We just rebalance the weights. In this case, it would be 50 and 5. So for every 55 users, 50 go to one endpoint and 5 go to that test endpoint. This is done automatically based on those health checks. So very straightforward to get up and running. All right, so getting our setup there, different weighting performances or maybe just different A/B style endpoints, pretty straightforward. Now into some of the fun ones. Performance allows us to do a quick check of latency. When a user performs a request, they have to be coming from somewhere. So we use their IP address and the edge location that they have come into to find out what is the lowest latency endpoint available. So via a performance method, we have 3 endpoints here: West US, North Europe, East Asia. We can look across all 3 of those and say, hey, my user is based somewhere in the US, so we should send them to the West US endpoint, it's down. That's okay. We'll look at the next available endpoint based on that network latency. So extremely useful if the thing you want is optimized speed. I've seen this used for scenarios just in Australia, having users that are based closer to our Sydney region, Australia East, be sent to that region, but if they're down in Melbourne, then we send them across there. Even in a local methodology, this can really help optimize how your users get redirected around the environment. Now I'm going to show you something that looks pretty similar, but I promise it is different. Geographic routing. Geographic routing is designed for compliance scenarios. Let's say you have customers that are based both in the EU and also in the US. You may have data residency requirements that you need to adhere to for both of those customers, but the requirements are going to be a little bit different. So what we can do is ensure that when a user request comes in, we do a geo lookup on their IP and direct them to the correct region for the compliance scenario you're looking to adhere to. But I want you to note this nested profile here in the middle. We can actually have multiple layers of profiles. If you want to combine geographic and performance, or geographic and weighting, or performance and geographic in some combination, go nuts with it. One of the common things I saw was having a primary check for geographic lookup. Am I in Australia or am I in the rest of the world? Secondary, we would then redirect based on region. Where am I based on latency? Then I would redirect based on weighting, A or B, primary or failover. You can really nest this to meet multiple different requirements. And remember, once the lookup is done, once Traffic Manager has done the processing, we send the user straight to the correct endpoint. If you're looking for the most efficient way to get someone to the right spot with ease, make sure you're looking at Traffic Manager. We're going to be looking at Azure Traffic Manager configuration. I'm going to take you across to the portal shortly, and we're just going to see how profile structures work and how the different configuration functions when we're looking at actually getting endpoints up and running. Let's dive straight into it. First thing that I want to just define is a little bit about endpoints. In Traffic Manager, there are a few different types of endpoints we can select. Now, primarily these are going to be endpoints that are leading us towards maybe a load balancing app or a web app that's somewhere located in Azure. But Traffic Manager does support reaching out to arbitrary FQDNs as well, fully qualified domain names, or IP addresses. So do note that it is possible to add different locations that are outside of the Azure ecosystem. This can be extremely useful if you are going to be failing over from the cloud back to an on-premises location, or maybe the opposite, failing from on-premises into the cloud once a migration is complete. There are many different ways that we can utilize these different scenarios, so it's important to know what's available. Also, don't forget about nested endpoints. These different endpoints can be nested one after the other to create some really interesting scenarios. Maybe we do a geographic lookup on a customer followed by a performance-based lookup to ensure that they are both getting the closest residency for what they need in terms of performance and are also adhering to any data requirements around where their data is stored. Let's jump into the portal and have a quick look at how everything fits together with a Traffic Manager profile. All right, so now we're in the portal. Let's go take a look at Traffic Manager and how this actually gets stood up. When you create a profile with Traffic Manager, there'll be a few less things in the portal than you might normally expect from a network resource. As Traffic Manager is global, we are going to need an endpoint that we can reach out to, Contoso Web 001 in our case. We'll need to pick an initial routing method, so we can pick multi-value, weighted, priority, geographic. Take your pick based on what makes sense for your particular environment. We'll need to deploy it to a resource group. I'm going to pick my core networking group here. but note that the resource group location is marked in gray. These profiles are being deployed globally, so all we're storing here is just some metadata. This is why Traffic Manager profiles are so good, because when a user comes in, no matter where they are in the world, we get them the most efficient pathway, or I suppose better said, the best pathway based on your requirements. Let's create this now, and I'll see you back here in a tick. And we're back. Here we can see Contoso Web 001. We have a DNS name, which is what we'll CNAME across to when we need people to access things that exist behind this Traffic Manager. We can also see things like the routing method selected. Do note that the status is enabled. You can actually create a profile and mark it not for enablement, so you can test things out, configure it, and not have to worry about someone accidentally hitting the site before you're ready. Now on the left-hand side, we're going to open up the sidebar. In the blade here, we're going to go through. We're going to actually take a look at endpoints first. These different endpoints, as I mentioned, can be either URLs or Azure endpoints, and those are the types you will have to select from. Do note the different options here, and honestly just pick the thing that makes sense for you. If the Azure endpoint I'm looking to point at is something that is a cloud point here, select the cloud service or the public IP you're looking to direct to, and then simply select the thing that makes sense. Note that these ones cannot be associated with the endpoint. That's because I've got them behind a virtual machine load balancing setup. So we would be better redirecting across to the load balancer itself. Down the bottom here, you'll also see health checks. Note that there is two different options here, and this is actually a call based on your architecture. We can either enable health checks at the Traffic Manager side, so it will do some sort of lookup on the endpoint to make sure that things are alive. It's just going to be a basic request just to get a keep alive back. But we can actually also disable health checks here. Now there are good reasons you would do this. If you are confident that everything is going to be up at that region, or you would prefer for compliance reasons that if the entire site goes down, the customer doesn't get redirected elsewhere, we can simply say always serve traffic. And then we rely on the regional health checks and the regional resiliency you've put in place to ensure that endpoint is up and running. These little tweaks that you can apply to endpoints make a big difference to your environment. So consider carefully based on the architecture of the application you're looking to protect. All right, at this point, we've got the basics down pat for a Traffic Manager to get it up and running, and it's ready for your configuration.